This is Chemistry 2, Unit 1, Intermolecular Forces, video number 3. In this video, we are going to talk about our second type of intermolecular force we are going to cover, and that is dipole-dipole IMFs. So with this, we're going to see that ion-ion covered ionic compounds, cation, anion, metal, nonmetal. The last three different types of intermolecular forces we're going to cover are on covalent molecules. So covalent, we're talking about things like water, carbon dioxide, ammonia. There is a distinction between covalent, polar and nonpolar. Dipole-dipole forces are going to be on covalent, polar molecules. So we have to talk about how to tell the difference between a polar and non-polar molecule. So with this, I'm going to look at four compounds. The first two are CCl4 and CCl3Br. Polarity for our case is going to be based on Lewis structures. You do not have to write your own Lewis structures. They will either be given to you or printed on something for you to look at. I'm just going to draw the Lewis structure for carbon tetrachloride, CCl4. And what we're looking at is how symmetrical the objects around the central atom are. So here we have four things surrounding this. They're all the same. So we could consider this one symmetrical. This one is nonpolar. If we look at CCl3Br, three things are chlorines and we have a Br. This is not symmetrical around here. The Br has a different electronegativity, so it is pulling on the carbon differently than the chlorine. So this one's going to have a little bit different charge separation. So this one is polar. If we look at NH3, N is in the middle, we have a lone pair of electrons. Anytime you see lone pairs of electrons, it's going to be polar. So any lone pair, 1, 2, or 3 lone pairs around the central atom is going to mean that it is polar. It's not symmetrical. And then we can have things like CO2. CO2 has two double bonded O's. So these no lone pairs, these two are opposite of each other, so they're pulling at the same rate, so this is symmetrical and this is nonpolar. And any diatomic element like N2, F2, O2, those are also going to be nonpolar. So going back to dipole-dipole, this is between covalent polar molecules. Anything that is covalent polar has dipole-dipole intermolecular forces. Because there's a separation of charge, one side of the molecule is a little bit negative, one side's a little bit positive. It can attract an adjacent molecule that's the same. So the positive and negative partial charges attract one another. And if we look at the proportionality statement with force, we're not going to use this like we did for ion-ion. I just want to explain how this one varies. So in this case, the force, which is going to be a lot smaller than ion-ion in magnitude, is based on the charge difference, but these are only partial charges, which are called dipoles. And if you look here, D is to the fourth in the bottom. What that means is the force is only strong over very short distances. So this intermolecular attraction between covalent polar molecules is only over a very, very short distance. So they have to be really close to one another for this to grab hold. which is why certain things have the properties that they do, why things are liquid or a gas at room temperature. So this comes into play and we'll be exploring that throughout these videos.